Okay, so we're going to continue talking about how to convert fractions to decimals. So in this video, we're just going to do a few examples and hopefully this will get you more comfortable with the process of actually converting this to decimals. So we're going to start with the first one. Now we know the first step is to perform a long division, because essentially what we want is to have a bunch of decimal places that would represent this number accurately. So we're going to write our 4 and our 11 here. And we're going to start right off the bat. We notice that 4 is greater than 1, so that means that we need to take the first two digits to begin with. Now, how many times can you fit 4 into 11? Well, you can only fit it twice, and then you're going to have 3 left over. So we're going to write 2 here, and then we're going to have 8. So 11 minus 8 is 3. Now, at this point, we have run out of digits, so we're going to have to introduce the decimal point. And we're going to have to do the exact same thing here. So the decimal point should always be lining up between the two. Now we're going to place a 0 here, and we're going to bring it down here. So now, how many times can you fit 4 into 30? Well, you could multiply 4 times 7. That would give you 28, which is close enough to 30. So let's do 7. Now 4 times 7 is 28. And then you're going to have 2 left over. And now we're going to bring back another 0 here. And we're going to have 20. So how many times can you fit 4 into 20? 5 times. And that gives you a remainder of 0. So we have successfully converted this fraction into a number with decimals. Now obviously you could do this in your calculator, but the whole idea of this thing is just to get you comfortable with the process of, okay, so how do we actually go about it? Because sometimes the calculator will give you a rounded up version. So what if you wanted the actual complete version of the number? Then this is why this can be useful in certain cases. So now let's do the next one. For this one, we actually have a mixed number. So remember, if we want to do long division on this one, we actually need to convert to a fraction. So we do the trick. We multiply by this, add that, divide by this. So 5 times 3, that's 15, plus 4 over 5, and that's going to be 19 on 5. Okay, so now we put the 5 here. Actually, let me do it here. We don't really know how many steps this is going to take, so it's better to have some room to work with. Now, once again, let's grab 2 digits. How many times can you fit 5 into that? Well, you can fit it 3 times, and then you're going to have a 4 left over. So now we have 4. We introduce the decimal point. Now we have a 0. Bring back a 0 down. So now 5. How many times can you fit in 40? Well, you can fit it 8 times. So at this point, it looks like we have pretty much just completely gotten that number. So we don't have any remainder. And basically that means that we're gonna have 3.8. If you wanted to check your answer, you could just put that in your calculator, and it should come out as the same number. So we know that's the correct answer. All right. So now let's do the next example. Just gonna erase this part here. And then let's see what we have here. So we have 11 here, 29. Let's see what that gives us. So grab 2 digits. How many times can you fit 11 into that? Twice. That's going to be 7 left over. Introduce decimal point. Now we bring a 0 down. How many times into that? Well, 6. That's going to give you 66. So remainder is 4. Bring back another 0 here. How many times into that? 3. So that's gonna be 33. Remainder 7. Bring back another 0 here. Let's see what this comes out to be. This is gonna be an interesting one actually, because it looks like it will be a recurring decimal. So let's see what happens. So 70. We know that we can choose 6 again, and that's gonna be 66. And notice what happens here. Actually, that should be a 4, just a 4 there. If we bring back another 0 here, notice that we're repeating the same sequence that we have here. We have 70, 40, 70, 40, which means that the next number has to be 3. So it means that this is a recurring decimal that is going to go on to infinity. So in this case, what we can write is 2.63, and then just a straight bar on top, because it is a recurring decimal. Alternatively, you can write it as by using 2 dots. So the notation is the same, both are valid, but usually we prefer this because if you had more than 2, it would look kind of silly that you have a bunch of dots on top of the numbers. So we're just gonna leave it at that. And basically that's how we know that it's a recurrent decimal. If during the process of long division you encounter that situation where the whole thing is just repeating over and over again. Now let's do the next one. So once again, we're gonna have to convert this to a fraction. So let's just do this one. That's gonna be 105 plus 4 over 15. That's 109 over 15. So let's do this here. So in this case, we actually notice that we can't really grab just 2 digits because 15 does not fit into 10. So we're gonna have to grab all 3. Now, how many times do you think you can fit 15 into this? Well, let's think about it for a second. So 15 times 6 is 90. If you add another 15 to that, that's 105. So basically that means you can multiply this by 7. So let's do 7 here. So 105, which is going to give you a remainder of 4. Now we introduce decimal point here. Bring back the 0 down. Now you can fit this twice into 40, so that gives you 30. That's 10. Bring back the 0. So that's going to be, we can multiply 15 by 6. So that's going to be 90. So let's do 6. That's 90. Remainder 10. Bring back another 100. Oh, interesting. So let's do, what should we do? 6 again. That's 90 again. And at this point, we can clearly see that the pattern is going to continue repeating. So in fact, all the other digits that are going to come after this one is just going to be 6. So that means that we can actually express this fraction as 7.26 dot. So it is also a recurring decimal, but in this case, only the 6 is going to repeat over and over again to infinity. Okay, now for this one, we're going to do something a little bit simpler. So how do we express finite decimal numbers? Essentially, this is terminating decimal numbers that we have here because the number of decimal places is not infinite. So these ones are pretty easy because we know, okay, so we just need to move the decimal point enough times so that this thing becomes a whole number. So in this case, we only need to move the decimal point twice to the right, which means that if we multiply this by 100, that's 24, but because we want to express this as a fraction, that's going to be 24 on 100. And that makes sense because if you had the decimal point here, dividing by 100 would actually move the decimal point twice to the left. For this one, we have the same situation, only that here we just need to do 3 decimal places. So that means that if we multiply this thing by 1,000, that becomes 2,385. And then we're going to divide this by 1,000. Same thing if you had something like this, 36.85713. In this case, all you will need to do is just multiply it by some factor of 10 that would actually move the decimal point 5 decimal places to the right. So that's going to become 85713. In this case, we have 5 decimal points to the right, so that's going to be 10,000 here. Alright, so that's pretty much it. So dealing with these kind of situations is pretty easy. We're gonna see in later on how to actually do recurring decimals as fractions. That one is a bit trickier, but there are some really nice tricks to get around that problem.